All right, folks, let's use this wonderful difference quotient for these functions. Okay, it's good algebra practice for sure in order to be able to simplify this radical, right, this square root function, to be able to calculate what is the derivative of this square root function using our difference quotient. Okay, so at first we start off by replacing the x in our square root with x plus h. Okay, and then we're going to subtract off the original and divide by h, and remember the calculus notation, we're going to take the limit of all of this. So our equation begins to look like this. We replace x plus h in here, and then we're minusing x plus 2. So you might remember, then again you might not, the way that we're going to deal with these radicals is by multiplying by the conjugate. So now our limit looks like that, right? We have this big old conjugate that we have multiplied by. It's the same as our radical expression up here, only it has a plus where there used to be a minus. So we have a top and the bottom multiplied by the same conjugate. So if you need to pause and catch up, go ahead and pause right now and catch up, because we're about to do some foiling distribution. So here is our FOIL. The radical goes away from our first term, right? And your O and your I cancel each other out. And then our last terms give you a minus x plus 2. Now let's do some simplifying to see how we can make this easier. I have an x minus x, right? Those go away. And I have a 2 minus 2. Those go away. So I am basically left with this formula. Oh, no, I'm not. Whoops. Big mistake. My B. We have this whole entire denominator down here, don't we? Whoopsie. So let's write that in better. Let's do that better. So on the top, yes, we just have h. But on the bottom, we have this huge radical denominator of root x plus h plus 2 plus root x plus 2. Can't forget about that part. Whoopsie, whoopsie. My brain. Okay, so now we cancel out the h's, right, because they divide and give yourself a 1. So I now have this wonderful radical in my denominator and a 1 in my numerator. Root of x plus h plus 2 plus root x plus 2. Okay, a lot of algebra. But now I can actually apply and do some direct substitution. I can now actually replace h with 0. Right? And now I can take the limit as h goes to 0 by plugging it in, and I have something that is not as scary. Well, maybe it's scary, I don't know. Root x plus 2 plus root x plus 2. All under 1. So if I have 2 of the same radicals, that means I have literally 2 of the same radicals. So 1 over 2 root x plus 2. Okay, and this is the equation of your derivative, what we use to find the slope of the tangent line at any value for x. Okay, so we did all of that wonderful work multiplying by the conjugate so that we could get this nice derivative. Okay, an equation that will tell us what the slope is at any value for x. So now that we can write an equation of our line with this knowledge. So I know that x equals 7. That's one of the parts that I need. I also need the y value, so f at 7, which is the square root of 7 plus 2. Root 9, which is positive 3. So that is my y value. And I also need the slope. So I need f prime at 7. F of 7 is the y value, and f prime at 7 is the slope. So I'm going to use the formula that I just got done calculating. So 1 over 2 times 7 plus 2 is 1 over 2 times the square root of 9, which hopefully you know is 3. And 1 over 2 times 3 is 1 over 6. So I have an x value of 7, a y value of 3, and a slope of 1/6. So I can plug that directly into my point slope form. Y minus 3 equals slope times x minus the x coordinate. And now I have an equation of the tangent line for my original square root graph when x equals 7. And here's a second example. Once again, we have to take the lim, right, the limit. So our derivative, the equation is found by taking the limit as h goes to 0 of f of x plus h. So I'm going to replace x with x plus h. So I'm going to change colors, right, because I'm adding something here that has changed to an x plus h plus 2. And I'm going to subtract the original 3 over x plus 2, all divided by h. Okay, so I replace in my original formula, right, my function x with x plus h minus the original function all divided by h. So here I have a fraction minus a fraction. And what has to happen in order for you to be able to subtract those, our denominators must be the same. So if we're going to shortcut this, right, we're basically going to multiply this denominator by that numerator and this denominator by that numerator. Okay, under a single denominator. So we're going to use this shortcut rather than do all of the math. So doing that gives us this amazingly crazy equation, right? 3 times x plus 2 minus another numerator 3 times x plus h plus 2, all divided by that single product of your two denominators. And we're still dividing all of that by h. Okay, so it's a good thing we can do some simplifying here in our numerator. So now we can see our 3x and our negative 3x cancel. Our positive 6 and our negative 6 cancel. And we are just left with a negative 3h in the numerator of our numerator. Okay, and in our denominator of our numerator, we still have this crazy product, x plus h plus 2 times x plus 2. Okay, now all of that was divided by h. Now I'm going to simplify this real fast by instead multiplying by the conjugate, or rather by the reciprocal. Sorry, I got the number. So we're multiplying by the reciprocal. If we're dividing by h, that's the same as multiplying by 1 over h. Okay, and this is handy because now our h's can cancel out on our top and our bottom. So now I have something that I can direct substitute into and simplify because my h's will no longer give me zeros places, but rather I can do some nice math with it. Okay, so direct substitute 0 into here, right? And that leaves me with just an x plus 2 as that binomial down there now. So I get negative 3 over, since there are two of the same factors, I'm going to write it as x plus 2 squared. Okay, and this is the equation for my derivative. Okay, I'm going to use this equation to find the slope of the tangent line at any value for x. Negative 3 over, parentheses, x plus 2 quantity squared. Okay, so that is an important thing to know because now down below, I actually want to take that and write an equation of the tangent line at x equals 1. So remember, here's my x value. I have to find my y value. So f of 1, which is 3 over 1 plus 2, right? We plug it into this equation. 3 over 3 gives me a y value of just 1. And now I'm going to find the f prime, right? The slope of the line at 1. And I'm going to use my slope formula that I just found, right? Using the difference quotient, painstaking algebra. negative 3 over 1 plus 2 squared. Okay, 1 plus 2 is 3. 3 squared is 9. Negative 3 over 9 reduces to negative 1/3. So I have my x value, I have my y value, and I have my slope. So the slope formula, point slope of y minus 1 equals the slope times x minus 1 is going to be my equation to find the tangent line. That is the equation of the tangent line for this graph at the point x equals 1. Okay, so there is a lot of algebra that goes into finding the equation for the derivative if you're using the difference quotient.